Hey, sixth graders, this is the try-its for 5-9. The first question talks about that skate ramp again. And they know that the skate ramp is 2.5 meters wide, and they have this board, not a skateboard, just a regular board because they're building a ramp with it. They have this board that they want to use that is 23.5 decimeters. A decimeter is about a little less than 4 inches, just for your own information there. If you're not used to using the metric system, it's about a little less than 4 inches. So 23.5 decimeters is how big the board is that they want to use, and they want to change it into meters to see if it's large enough to fit this space that's 2.5 meters wide. So we're going to find the metric conversion here that that has the decimeters and the meters. Let's see if we can find it. There it is. There are 10 decimeters in a meter, which makes sense because a meter is about 40 inches, and decimeter would be taking that about 40 inches and splitting it into 10 parts. So that's where that 4 inches is coming from. Okay, so here we go. So we know that what we have is 23.5 decimeters, and we want to change that into meters. So we're going to do this kind of dimensional analysis. We're going to multiply it by the conversion factor here. Remember, when you're multiplying these, you want your units to cancel out. And since it's multiplication, that means whatever is in the numerator of one cancels out what's in the denominator of the other. So we're going to put decimeters on bottom. So 10 decimeters on bottom and 1 meter on top. And remember, this is technically, this is 23.5 over 1. Makes it easier for me to remember that I'm multiplying fractions here. So this decimeter unit and this decimeter unit cancel out. 23.5 times 1 is 23.5, and 1 times 10 is 10, and 23.5 divided by 10 is 2.35 meters. Because the unit meter is the only one that didn't get canceled out. So that's what we're left with. So the question is, we need that space. That space is 2.5 meters. The board you want to use is 2.35. So it's not big enough. The other way to figure this out is to say, okay, let's ignore the 23.5 for just a second, and instead, let's think about it this way. If the space we want to fill is 2.5 meters, maybe instead let's change that into decimeters to see if to see how many decimeters wide the board needs to be, and then compare that to what we have. So if we're going to change that in, we're going to use this same conversion rate over here, and we're going to do multiplication again. We definitely know we want meters to be on the bottom so that those two meter words can cancel each other out. And so it's going to be 1 meter on the bottom and 10 decimeters on the top. DCI. And this is over 1. And this unit and this unit cancel each other out. 2.5 times 10 is 25. So the board that we use has to be 25 decimeters long, and the one we have is 23.5, so that's another way to prove that no, it is not long enough. Example 2 typically doesn't have a try it, but once again they've shown 2 different ways to come up with the answer. In the first way, we know that there's 2.2 hectoliter capacity, so we're trying to figure out how many liters that needs to be which is going to be this down here space. So you find the conversion rate over here. In this one, notice the equal sign in the middle. When the equal sign is in the middle like that, then the fraction on the left and the fraction on the right, where if you put the liters on bottom, it's in the bottom on both of them. The other way to do it over here when you're using multiplication to find when you're using dimensional analysis, this is the one where if hectoliters are in the numerator, then they're going to be in the denominator on the other fraction. So when you're multiplying, the units go into the opposites, and when there's an equal sign in between the units, or if they're in the numerator, they'll both be in the numerator. So you're essentially coming up with the exact same answer in both of these. So it really kind of comes down to the way that you like the best. So let's look at the next question and see what we need to solve for that. Okay, so for example 3, let's check this out. If you read it kind of carefully, there's 0.25 liters of red paint, 0.25 liters of blue paint, and 0.45 centiliters of white paint, and we want to know how many centiliters of paint there are in the mixture. So there's, a couple ways you can do this. Definitely we should add together the red paint and the blue paint because they're both in the same unit of measurement. So 0.25 liters red and 0.25 liters blue so far would make 0.5 liters of paint. The 4.5 centiliters, we're gonna need to not forget to add that in at the end. So we want to take that half a liter of paint and we want to change it into centiliters. And I can tell by looking at my metric units of capacity that this right here is the one that I'm gonna want to use because 100 centiliters is equal to 1 liter. And right now we have half a liter. Well, wait a minute. Is it going to be this easy? This seems too easy. Half a liter, if 1 liter is 100 centiliters, then what's half a liter? Well, not just be 50. I'm pretty sure. Just a second. Let me check my calculation. Well, let's pretend it's a little more difficult than this. Let's at least just set it up. So 0.5 liters, I want to multiply that by 100 centiliters over 1 liter. And once again, since I am multiplying these two, I want to make sure that since liters is in the numerator over here, on the left I want it in the denominator on the right. My son is watching like videos of people playing video games, and I keep thinking I'm going to hear Leroy Jenkins behind me, but I'm not. Okay. Anyway, let's keep going. So these liters cancel each other out. This guy is the only one left. If you multiply straight across, 0.5 times 100 is 50, and 1 times 1 is 1. So that's 50 centiliters. But don't forget, you have to add in the 4.5 that we had of white paint. So that's a grand total of 54.5 centiliters of paint. That's it.